In Kotlin, everything is an object. So if we look at, for instance, an integer, if I say val my int here, int is an actual object in Kotlin. And we have different built-in objects for numbers. So we have integer, we have a byte. Let's just change that to number so it actually makes sense. My number, we have a byte, we have, for instance, long, we have float, as well as double. So we can see that we've got the built-in types for all of these different numbers. And you can see if we navigate to it that is actually an object. It's a class, so that's built in. This is somewhat different to Java, in which you have actual primitive types. Now, if I want to do something like my double, and I say, or let's actually do this with long. So let's go ahead and say, for example, long, and I say 10. Okay, I just said that one of the main benefits of Kotlin is not to have to explicitly put the type. So I don't want to do this. I don't want to do long equals 10. I just want to do my long equals 10. The problem is, of course, that Kotlin doesn't know if this is an integer or if this is a long. So we have a few literal constants that can help us. So if I want to create a long and initialize it with a value, I can just put an L after the value. And now Kotlin will realize that that's a long. If I want to do a float, I could do something like 100f, f meaning float. If I want to do hexadecimal, I do my hexadecimal and then 0x0f. Sorry, that's a 0 there. And let's say, for instance, last but not least, my binary, I could do 0xb01. So that declares a binary. So again, it's using the type inference and then combining that with literal constants to cut down on the amount of code that we write. One thing to take into account in Kotlin when it comes to numbers is that we don't have any kind of explicit conversion. So let's say that I have my int here that is 100. And if I do my long again, and I do my int, it's going to assign it because it's not initialized. It thinks that, again, this is an integer. So if I go ahead and do, for example, long, now you can see that it says type mismatch because there's no implicit conversion. However, there are a bunch of helper functions, and we'll see how these are actually implemented later on, that allow me to do conversions. So I can say my int to long, and that will convert it. So no explicit conversions in, no implicit conversions in Kotlin. You have to do everything explicitly. There's also, of course, when we're working with binaries, there's bitwise operators such as shift left, shift right, and, or, etc. When it comes to strings, so let's look a little bit at strings. Again, we have characters and strings. So I can have my char equals a, and a single quote will declare a character for me. I can have my string, which is double quotes, and this is my string. And then I can do, for example, escape characters like you would expect in any language. So I could say escape characters here, and then do a new line, and use the backslash and then n to indicate a new line. And we can also have multiple lines. So for instance, if I have some strings that are on multiple lines, I could just say, let me start here and say hello, and then I can just create a second line. This is a second line, and then concatenate a third line. Now, this is not really that nice because, I've got this plus sign, and really all this is doing is basically just the same thing as that. It's just I'm putting it on multiple lines. But if I actually want multiple lines as part of the string, I can do it in a different way. So I would do 3 quotes, and then this is a string, and this is another line, and then I can end that, and that would give me multiple lines. So this is a multi-line string on multiple lines. Okay. One other thing that Kotlin provides is string interpolation. So we've seen this already with the hello world, etc. If I do, for example, years equals 10, and then a message here, for instance, a decade is, and now I don't have to do string concatenation years. What I would do instead is string interpolation. So I use the $sign and say a decade is 10 years, and that would provide me with the ability to do string interpolation using the $sign. We can also invoke methods in string interpolation. So let's say, for example, I have val name equals Mary, and then I do val another message equals length of the name is, and then instead of obviously referring to name here, which would be $name, I want to actually get the length of the name. So we know that a string has a length function which returns the function, which returns the length of the function, which returns the length of the name. So what I could do is use that directly in the string interpolation by using the curly braces. Anytime it's not just a simple substitution of the variable, but it's calling, for example, a method on that variable, etc., I have to use the curly braces. And that would give me the length of the name. If you use curly braces where it's not required, like here, again, IntelliJ will give you a hint and say you can actually remove these curly braces. But when you're calling methods or doing complex operations, you can even do ifs, etc. inside the string interpolation, then you do need the curly braces. Now, the standard library includes many functions that work with strings, characters, etc. And we'll see some of these when we look at the part around standard library.